told you again to leave those poor people alone. I want you to stay away from their house. Don't torment them.
Hey, what's up everyone? Welcome back to the channel. Today we're gonna continue learning Python, and if you're new to the channel, please subscribe to the channel. That's gonna help me a lot. To introduce myself, my name is Alex, and what I want to do, I want to learn programming from scratch because I know nothing in programming, and Python is the first language that I'm learning. The reason that I decided on last month, I decided to learn programming because last September I quit my job and I started to do some Bitcoin. And then the technology is so impressive about blockchain, smart contracts, and all this like Web3 technology is so impressive to me. That's why I want to be able to work on that field. That's my next dream job. I wish you can help me achieve that dream by subscribing to the channel, turn the notification button, and then in the comments, write down anything that might help me through the journey. I'm still beginner. I have a lot to learn, and today we're gonna continue with the same tutorial with mosh. I'll leave the link in the description if you're interested to learn. And let's jump into it.
Show you something really cool that you can do with dictionaries. So here we have this program. We can type a message like good morning, followed by a smiley face. When we press enter, we get this beautiful smiley face. Or we can type is a list. So we can unpack this list into 3 variables.
Dictionaries. That's today's
In this
lesson.
tutorial, I'm going to talk to you guys about dictionaries in Python. We use dictionaries in situations where we want to store information that come as key value pairs. Here's an example. Think of a customer. A customer has a bunch of attributes like name, email, phone number, address, and so on. Now, each of these attributes has a value. For example, the name can be John Smith, the email can be john@gmail.com, the phone can be whatever. So what we have here is a bunch of key value pairs. So in this example, our keys are name, email, and phone, and each key is associated with a value. So this is where we use a dictionary. With a dictionary, we can store a bunch of key value pairs. So let me show you how to define a dictionary in Python. Back to our program, I'm going to define a variable, customer, and here we set it to curly braces. With these curly braces, we can define a dictionary. In this example, we have an empty dictionary that doesn't have any key value pairs. Now we can add one or more key value pairs in between the braces. So let's add a key value pair here. I'm going to set the key to name and the value to John Smith. Then we add a comma to add another key value pair. So let's set age to 30. Let's add another key value pair is underline verified. And we set this to a Boolean. Now what matters here is that these keys should be unique. So if I add another key value pair here, let's set age to 40. Now look, PyCharm has highlighted the age key because we have duplicated that, and that's not allowed.
You cannot
So
do
each
that,
key
okay.
should be unique in a dictionary, just like the dictionaries we have in the real world. In a real dictionary, we have a bunch of words and their definition. Each word is listed only once in a dictionary. We don't have the word book twice. So let's delete this second duplicate key value pair. So the keys should be unique. I mean, this,
I think I
for
already
example,
saw
if this
that.
dictionary,
So what I didn't
have-
understand is this.
each of these keys
This thing.
to a
this
word. So we
code I
can map the
didn't
digit
understand.
1 to the word 1. We can map 2 to TWO. You got the point. So let's define a dictionary. We can call
Okay.
it digits underline mapping. Now in this dictionary, I'm going to add a few key value pairs. 1, we map it to 1. 2 to 2.
Okay.
3.
Yeah, last time
to
I
3,
wrote it,
and
but I didn't really
finally
understand
4
what
to
is
4.
it about.
Now, technically, we should add all the digits from 0 to 9, but I don't want to waste your time typing repetitive things here. You got the point. So let's move on. Now we need to loop through the phone string. So for character in phone, we get each character and then use it to access a key value pair in our dictionary. So digits underline mapping, we can use square brackets or call the get method. I would prefer to use the get method. So in case the user enters some character that is not part of our dictionary, our program is not going to yell at them. So we call the get method and pass this character as the key. And if we don't have this key, we can supply a default value like an exclamation mark. So with this, we'll get a word. Now we need to add this word to an output string. So we can define an output string. Initially, we set it to an empty string. In each iteration, we get this and add it to our output string. So we type output plus equals this. And we should also add a space at the end. So the words are not close to each other. Okay? That's all we have to do. Now finally, let's print this output, run our program. So I'm going to type 1, 3, 4, 5. Let's see what we get. We get 1, 3, 4 with an exclamation mark.
Okay. All right. This is new to this part. I don't understand, to be honest. I don't understand this part. So, image converter. Okay.
In this tutorial, I'm going to show you something really cool that you can do with dictionaries. So here we have this program. We can type a message like good morning, followed by a smiley face. Then we press enter. We get this beautiful smiley face. Or we can type I am sad with a sad smiley face, and it gets translated to this beautiful emoji. So this is another application of using dictionaries. We have a dictionary that maps these characters into smiley faces.
Okay.
So let's go ahead and build this program together.
Yeah.
We start by calling the input function. Here we pass a greater than symbol as an indicator for the user to type a message. We get that message, store it here. As you know, that is a string. Now we need to split the string by a space. So if the user types good morning with a smiley face, we want to break this down into 3 words: good, morning, and smiley face. To do that, we can call the split method. So we call message.split and pass a string with 1 space as the separator. What this method does is basically it goes through the string, and anywhere it finds this character, in this case a space, it uses that as a boundary to separate this string into multiple words. And then it will return a list. Let me show you. So let's store that here, words, and then print it on the terminal. Let's go ahead and run our program. So if we type good morning sunshine, enter, we get a list with 3 items. Each item is a
Wait. What? Please subscribe. Okay. Please subscribe. Oh, I see. Interesting, my man.
String.
This is so interesting.
Now, back to our program, we need to define a dictionary for mapping special characters like these two into a smiley face. So we can call that emojis, set it to curly braces. Here we add a key value pair, a smiley face, and we map that to a string. In the string, we want to add an emoji. If you're on a Mac keyboard, you can press Control, Command.
Wait. This is so complicated to me. I'm sorry. I don't understand. So this means, yeah,
and space, and this should bring up this emoji box. If you're on Windows, honestly, I really don't know how you can do this, but there must be applications that do this
I don't know also, but let's say this way.
for you. So let's go ahead and pick this happy smiley face. Good. Now let's add another key value pair for a sad face. We map this to this face here. Good. So we have a list of words. Now we need to loop through this list, get each word and potentially map it to an emoji. So we can write a for loop for word in words. Now
Wait. Just, I don't understand. For word. Okay, in words. What should we do? Alright.
we want to go to our dictionary and see if you have an item with this word as the key. If you have an item with that key, then we'll get its value. Otherwise, we want to use the same word. So if the user types good morning, we don't want to translate those words. We just want to return those. So that is the case where we use the get method to supply a default value. So we want to get an item with the key word. And if we don't have an item with that key, we simply use that word as the default value.
Word.
Now, similar to the exercise that we did in the last tutorial, we
I
need
didn't understand. I'm sorry. I
So-
need to go back.
to loop through this list item with that key, that word,
Okay,
and
let's see.
potentially map it to an emoji. So we can write a for loop for word in words. Now we want to go to our dictionary and see if you have an item with this word as the key.
Alright.
If you have an item with that key, then we'll get its value.
Yeah.
Otherwise, we want to use the same word. So if the user types good morning, we don't want to translate those words. We just
Right.
want to return those. So that is the case where we use the get method to supply a default value. So we want to get an item with the key word. And if we don't have an item with that key, we simply use that word as the default value. Now, similar to the exercise that we did in the last tutorial, we need an output variable. So let's define that here, output, set it to an empty string. Now back to line 9, we get the return value of the get method and add it to our output variable. So output plus equals whatever we get from the get method. And finally, we need to append a space at the end. That's it, we're done. So let's print the output and run our program. I'm gonna type good morning, sunshine, with a smiley face. We get that, beautiful. Let's try a sad face as well. I am sad. Too bad.
It worked.
Beautiful. So as you can see, dictionaries have a lot of use cases in real applications.
It worked. Well, I can't say I understand, to be honest, but it worked. But here we need space. Sad. Alright. It worked. Oh, I see. So output is empty. Here we add the empty output to the emoji that we're using plus the word that we're already put in here, right? But what does this mean? Isn't it supposed to be plus? Interesting. All right. Functions.
Here's a solution from the last tutorial where we created an emoji converter. Now, so far we've been writing all our code right here in app.py, but as our programs grow, we need a better way to organize our code. We need to break up our code into smaller, more manageable, and more maintainable chunks, which we call functions. So a function is a container for a few lines of code that perform a specific task. For example, you have learned about a few of the built-in functions in Python like print and input. Each of these functions have a purpose. They know how to perform a specific task. So when building large, complex programs, we should break up our code into smaller, reusable chunks, which we call functions, to better organize our code.
Okay.
And that's what I'm going to show you in this tutorial. So let's write a simple program for printing a greeting message. So we're going to do a print, hi there, and let's add another message, welcome aboard. So here we have a simple program with only 2 lines of code. Now let's say these 2 lines, potentially we're going to need them in other programs. So we can put them in a function that we can reuse. Let me show you how to do that. So we start typing out def, that is a reserved keyword in Python, and it's short for define. When Python interpreter sees them in other programs. So we can put them in a function that we can reuse. Let me show you how to do that. So we start typing out def, that is a reserved keyword in Python, and it's short for define. When Python interpreter sees this, it knows that we're defining a function. Next, we need to give our function a name. Let's say greet underline user. So all the best practices you learn about naming your variables also apply here, which means you should name your functions with lowercase characters. If there are multiple words, you need to separate them using an underscore.
Okay.
And you should always, 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 always use meaningful and descriptive names for your functions. So here we're defining a function called greetUser. After that, we need to add parentheses followed by a colon. Now, you know that whenever we add a colon at the end of a line, we're telling Python that we're defining a block of code. So when we press enter, the next line is indented. Now, any code that we write here will belong to this function. So I'm going to move these 2 lines, these 2 print statements inside of our function. We can simply press tab to indent them. Beautiful. Also, let's remove this extra line break. That is better. So these 2 lines now are part of our greet user function. So whenever we call this function, these 2 lines will be executed.
Okay.
Now let's remove indentation. So here we are outside of our function. Let's do a print statement and print start. After that, let's call our function. So greet user. And finally, let's do another print statement and print finish. Now we have this little warning here, this underline. If you hover your mouse over this line, this tooltip is telling you that we should add 2 blank lines after function.
Wait. Can you just go back a little bit? I'm sorry.
Definition. And finally, let's do another print statement and print finish.
Okay.
Now we have this little warning here, this underline. If you hover your mouse over this line, this tooltip is telling you that we should add 2 blank lines after function definition. This is coming from PEP 8, which is a document that defines the best practices for.
What are you talking about? Two blank lines after class or function. I don't understand.
Formatting our code. We'll look at that in the future. So for now, to make PyCharm happy, let's add an extra line break after this function. So whenever we define a function, we need to add 2 line breaks after.
Really?
Okay.
This is the rule?
So
okay.
now let's run our program and see what happens. All right, so we get 4 messages on the terminal. First, we get this.
Wait. What's going on? It's not working for me. Hello? Am I still here? Oh, but I want this one. What's going on? Start. Hi there, welcome aboard. Yeah. Okay.
Start message. Then we get the messages coming from our greet function. So hi there and welcome aboard. And finally, we see the finish message. So let me explain the flow of our program. When Python runs this code, it doesn't actually print these two messages on the terminal because these lines of code are inside of this function. So they will only get executed if we call this function. If we don't call this function, these lines will not get executed, okay? So the execution of our program actually starts here. The first message that we see on the terminal is the start message. After that, Python sees that we're calling the greet function, so it will jump over here and then execute these two lines. Then it will jump outside of this function and continue the normal execution of our program, so it will print the finished message on the terminal. So this is how functions work. Also note that the order of this code matters. So here we're calling the greet function after we have defined it. If you try to call it before you define it, you will see an error. For example, if we call the greet user function right here, see, we immediately get this red underline, which says unresolved reference greet user, which basically means Python doesn't know what is this greet user. It's not defined anywhere.
Makes sense.
So we always define our functions first and then call them.
All right. Parameters. Okay.
Here's the function we created in the last tutorial. Now I got a question for you. What is the difference between calling this function and the print function of Python? The difference is that the print function takes some information, in this case, the message that we want to print, but our greet function doesn't take any information. Wouldn't that be nicer if you could pass the name of the user here, and then instead of saying hi there, we could print the name of the user? So in this tutorial, I'm going to show you how to pass information to your functions. And that is pretty easy. So back to the definition of our greet user function. Inside of this parenthesis, we can add parameters. These parameters are placeholders for receiving information. For example, we can add a name parameter, and with this, we can pass the name of the user when calling this function. So let's pass John here. Now, when we call this function and pass this value, this name parameter will be set to John. So it will act like a local variable that we define inside of this function. Just imagine we didn't have this parameter, and instead we had a variable like name that was set to John. Now here, we could simply print the name of this user. So we could use a formatted string and print the value of the name variable, right? Now, we don't really have this local variable defined in this function. We have a parameter. It's exactly the same thing. So with these parameters, we can receive information in our functions. Now let's go ahead and run this program. So take a look. We get, hi John, welcome aboard. We can take this to the next.
Wait. Didn't change for me. Still hi there. Print. Hi there. What's going on? It's exactly the same. Name. It says name here. Oh, yeah. F. Oh no. Wait. F and here, and then here, name, right? Yeah. Hi John. What if it's Alex? Hi Alex. Cool. Okay.
It's exactly the same thing. So with these parameters, we can receive information in our functions. Now let's go ahead and run this program. So take a look. We get, hi John, welcome aboard. We can take this to the next level. Now we can call this function one more time. So greet user, and this time supply a different name. Let's say Mary. So we are reusing our greet function and passing it a different value.
But how come you have two now? Greet user and Mary. Okay. Oh, two times. It's gonna.
Imagine if we didn't have this function, we would have to repeat this line twice. Once for hi John and another time for hi Mary. So this is the benefit of defining functions. We can take a few lines of code that have a specific purpose and put them inside of a function. So now let's run our program one more time. There you go. So we get, hi John, welcome aboard. Then we get, hi Mary, welcome aboard. Now note that when a function has a parameter, we are obligated to pass a value for that parameter.
Right.
So if we remove John from here and run our program, we get this type error, greet user missing one required positional argument.
Right.
Argument in programming is the value that we supply to a function. So back to this example, Mary in this case is an argument that we pass to the name parameter. A lot of programmers don't know the difference between parameters and arguments and think they are the same, but they are not.
What are the difference? Let's see. What's the difference between arguments and what? Can you go back?
That we supply to a function. So back to this example, Mary in this case is an argument that we pass to the name parameter. A lot of programmers don't know the difference between parameters and arguments and think they are the same.
And parameters. Okay. Argument is the actual value of the variable that gets passed to function. Parameter is something you have to fill in when you call a function. Let's see this. Oh, no, here. Invoke call. Let's see this. Can it be bigger a little bit? No, can't. No, this is not what I'm looking for. Just go back. Okay. Difference between argument and let's see. Difference between arguments and parameter. Overview. Many programmers use the term argument and parameter interchangeably, or they have different meanings. Hence, we'll look at the difference between an argument and parameter in this tutorial. Okay, a parameter and arguments. Let's see. What is that? Pseudocode example to show clear definitions, terms, parameter, and arguments. In fact, a method or function in this program takes two numbers as input and outputs the sum of those values. Function sum a/b, sum a plus b, return function main a equals 5, b equals 10, sum 5, 10, print sum, return. Pseudocode example, parameters. Okay, this is a function, and here the parameters are the variable that we can define in the function declaration. In fact, we utilize these variables within the function. Also, the programming language in the function description determines the data type specifications. These variables facilitate the function entire execution. In addition, they are known as local variables because they are only available within the function. Okay, now let's understand these variables in details. Help the example above. The function sum a and b contains two values inside parentheses a and b. So a and b are the parameters. In fact, these are two local variables within lifetime limited to the function. They can also take any values that are given to the function when it's called. Arguments. The arguments are variables given to the function for execution. Beside the local variables on the function takes the value of the argument and therefore can precede these parameters for final output. Oh, here, yeah, let's read this thing. Arguments, we use the variables in the function to send the value to the calling function, the receiving function. Parameters, we define the parameters when defining the function. Okay, I think I understand that. Let's continue.
But they are not. Parameters are the holes or placeholders that we define in our function for receiving information. Arguments are the actual pieces of information that we supply to these functions. Okay?
Yeah.
So let's bring back this John string. Okay? Now we can also define multiple parameters. For example, let's rename this parameter to first name. As I told you before, you can right click here, go to refactor, and then rename. Or preferably, you can use a shortcut. So the shortcut for this on Mac is Shift and F6. And this brings up the rename dialog box. Here we can change this to first underline name. Now we can add a second parameter, so comma, followed by last underline name. So back to our formatted string, let's also print the last.
Wait, what is that now? Right, last name. Okay. Last name.
Name, beautiful. So here when calling these functions, then we can
Oh, okay. John Smith, right?
apply another argument. So John Smith, and let's delete this line. We don't really need it anymore. Run our program. Take a look. Hi, John Smith.
Right. Cool. So what if I want to add the third one? Age, for example, and here, age, and then here, we just write like 28, let's say. Oh, right, okay. Wait. Let's say country. All right. Here, country. But here, listen. Here from. Ha. Say the US, for example. Hi, John Smith from the US. Welcome. Oh, cool. All right. Alrighty. We got
So
it.
in the last tutorial, you learned that whenever we define parameters for our functions, we should always supply values. Otherwise, we'll get an error.
Right.
Let's look at that error one more time. So I'm going to delete the second argument and only pass John. Run our program. We get this message.
You need to fill it, yeah.
Greet user, missing, 1, required, positional argument. So these arguments that we have here, like John and Smith, we refer to these as positional arguments, which means their position or order matters. In other words, the first argument we add here is the value for the first parameter, and the second argument is the value for the second parameter. So if we change their position or order, we'll get different result. Let's take a look. Let's pass Smith first and then John. Okay. Delete. That's good. Let's go with this.
Doesn't matter.
So
Yeah,
instead of
it's
getting
just gonna
hi
Smith
John
John.
Smith, we get hi Smith John.
Right.
So that is the reason we refer to these arguments as positional arguments. Their
Right.
position or order matters. But in Python, we also have keyword arguments, and with those, the position doesn't matter. Let me show you how they work. So let's say here we want to pass John as the value for the first name parameter. We can simply specify that here. So first name equals John. Now what we have here is a keyword argument.
Oh.
So this combination of having
Let's
the
see.
parameter name followed by its value is what we call a keyword argument.
Interesting.
And with these keyword arguments, the position doesn't really matter. So here we're supplying John as an argument for the first parameter. Now, similarly, we can use a keyword argument for Smith. Let me show you. So
What if I
last
change
name
this to
equals
first name and
Smith.
then here last
So now we
name?
have two keyword arguments.
Hi,
So with these
Smith
keyword
John,
arguments,
right.
we don't have to worry about the
Wow.
order of the parameters.
Okay.
That doesn't mean we should always use keyword arguments. Not really. Most of the
just
time,
easier,
we use
yeah.
positional arguments. But in certain situations, these keyword arguments help us improve the readability of our code. So on line 7, it's quite clear that we're supplying Smith as the last name and John as the first name.
Right.
Now, in this particular example, even if we didn't have the keyword arguments, just passing two positional arguments like John and Smith would be sufficient because it's easy to guess what is the purpose of these arguments. But sometimes you're dealing with functions and you're passing numerical values to them. In those situations, it may not be quite clear what these values represent. Let me show you an example. Let's say we have a function for calculating the total cost of an order. So we can call that calculate underlying cost. So when calling this function, we need to supply three pieces of information. One is the total cost of all the order items, let's say $50. The other is the shipping cost, let's say $5. And the last piece is a discount, let's say 0.1. Someone reading this code may not be sure what these three values represent.
Right.
In this case, we can improve the readability of this code by using keyword arguments. So we can prefix each value with the name of the parameter they target. For example, we can set total to 50 and then shipping to 5 and discount to 0.1. Now, if we give this code to someone else, they can immediately tell what these values represent. So that is the power of keyword arguments. So here's what I want you to take away. For the most part, use positional arguments. But if you're dealing with functions that take numerical values, see if you can improve the readability of your code by using keyword arguments. You simply prefix the arguments that you pass with the name of their parameters, and this will increase the readability of your code. Now, there is one more thing you need to know about keyword arguments. These keyword arguments should always come after positional arguments. Let me show you what I mean. So, back to our simple greet user function. Let's use a keyword argument for the first name. So, let's set first name to John and see what happens. Look, we immediately get this error. Take a look. Positional argument after keyword argument. So when calling this function, we're supplying one keyword argument and one positional argument. And Python doesn't like this. So if you're mixing positional and keyword
either
arguments,
do them all or
you should
leave them
always
all.
use the positional arguments first and then the keyword arguments. In other words, let's remove this keyword argument here. So John is now a positional argument, is targeting the first parameter, right? Now, after this positional argument, we can supply any number of keyword arguments. So if we set last name to Smith, look, Python doesn't have any problem with this because we're adding a keyword argument after a positional argument. So let's quickly recap. For the most part, use positional arguments. If you're dealing with functions that take multiple numerical values and it's not quite clear what those
Can I try this? I don't know why he first name equals doesn't work. Position argument follows keyword argument. Okay. But what about here? Last name. It works. First name. Okay.
values represent, use keyword arguments to improve the readability of your code. And finally, if you're passing both positional and keyword arguments, use the keyword arguments after the positional arguments.
Return statement. I didn't
So far, you have learned
understand
how to
this.
create functions
I didn't
and
understand
send them
that.
information using their parameters. In this tutorial, I'm going to show you how to create functions that return values. This is particularly useful if you're doing some kind of calculation.
Can I just like, what does the return do in Python? return statement is used to end the execution of the function call and return. Wait. The return statement is used to end the execution of the function call and return the result value of the expression following the return keyword to the caller. The statements after the return statement are not executed. Okay.
Your function, and you want to return the result to whoever is using your function.
Okay.
Let me show you. So let's start by defining a function called square. This function simply calculates the square of a number. So we need to add one parameter here, that is our number. Now here we want to calculate number times number, that is the square of a number. Now to return this number outside of this function, we simply use the return statement. So return. Now our square function is very simple. It only has one line of code. But in a real program, you might have a function that has 10 lines of code to calculate something. So this return statement is return. So we need to add one parameter here, that is our number. Now here we want to calculate number times number, that is the square of a number. Now to return this number outside of this function, we simply use the return statement. So
what do you mean return? Like what does
now our
that
square
mean?
function is very simple. It only has one line of code. But in a real program, you might have a function that has 10 lines of code to calculate something. So this return statement is very valuable. With that, we can return values to the callers of our function. So with this, when we call the square function, let's say we give it 3, now this function returns a value, just like the input function of Python. This input function waits for the user to type something and press enter, and then it will return the user's input as a string. So we can get it and store it in a variable like this, right? We have the same story with our square function. So our square function returns a value. We can simply get it and store it in a variable. Let's call that result. Now we can print result on the terminal. There you go. So result is 9. We could also pass this.
All right. Error. Good job. Good job, my dear. Oh. Print result.
This function call directly inside of the print function without defining a separate variable. Sometimes this is useful for writing shorter code. So in this case, we don't really need this result variable. We simply want to print the square of 3. So we could simply pass this function call right here as an argument for the print function. So let's delete this variable. Now our code is shorter. So with this, we're calling the square function. This returns a value, and we'll pass that value as an argument to the print function. Okay? When we run this program, we get the exact same result. There you go. Now, what happens if we don't use a return statement in our function? So in the last example, we simply used a print statement. Let's temporarily remove this return statement and print the result on the terminal like this. So let's run our program one more time and see what we get. We get two things on the terminal, the number 9 and none. What is happening here? Well, when Python interpreter executes this code, first it will call the square function. So the control moves to the square function. Here we calculate the square of this given number and then print it on the terminal. That is the reason we see 9 right here. Now, by default, all functions return the value none. So if we don't have a return statement here, by default, Python returns none. None is an object that represents the absence of a value. It's like nothing, or null in C, C++, Java, and JavaScript. So in this example, we didn't have a return statement, and by default, Python returned none from this function. So after this square function is executed, the value none is returned and passed as an argument to the print function. That is the reason we see none on the second line. So here are the two things you need to take away from this tutorial. By default, all functions in Python return none. You can change that. So if you have a function that calculates something, you can return the result using the return statement.
I'll pretend that I understood that.
Here's the code for our emoji converter program that we wrote earlier. If you missed that tutorial, make sure to go back and watch it. As I told you before, there is a table of content right below this video in the description. So you can simply click on the emoji converter tutorial to watch it. Now, your exercise is to reorganize this code using a function. So I want you to extract a function in this code. Because this algorithm for converting these smiley faces into emojis is something that we probably want to use in a lot of different applications. We can use it in a chat application, in an email application, and so on. We don't want to write all this code every time. We want to convert these characters into smiley faces. So out of all these lines of code that we have, from line 1 to line 10, the lines 2 to 9 belong to our algorithm. All these lines together implement this feature. So you should put these lines in a separate function. Now, why don't we have the input in that function? Because the input can come in different forms. Currently, we're using the input function to receive the input from the terminal, but in other applications, we might receive the input from a graphical user interface. So the input can come in different forms. We don't want to put that in our function because this line will not be reusable. We want to give our function
Maybe
the actual message as a string. We don't care how we got that message. In one program, we might get it from the terminal.
Okay.
In another program, we might get it from a graphical user interface. So that is the reason this line of code should not be in that function. By the same token, you shouldn't include the last line in that function because what we do with the output is different from one program to another. In this program, we're printing the output. In another program, we might send that output as an email or as a response in a chat application. So as a general rule of thumb, your functions should not worry about receiving input and printing it. These lines of code should not belong to your functions. So go ahead and reorganize this code by extracting a function.
I didn't understand.
All right, on the top, first we need to define our function. So we type def, give our function a name like emoji underline converter. So the name of this function clearly tells me what it does. Each function should be responsible for one and only one task, and that task should be clearly explained in the name of the function. Okay? So our emoji converter function should take a parameter, we call that message. That is a string, right? Colon. Now we need to move the lines 5 all the way to the end of our for block into that function. So let's select all these lines. We can cut them from here by pressing Command and X on Mac or Control and X on Windows. Then we paste them here. As you can see, these lines are automatically indented, so they are part of the emoji converter function. If this didn't happen on your computer, make sure to select these lines and use the tab to indent them. All right, so here's our emoji converter function. Beautiful. Now, after that, in the main flow of our program, first we get the input from the user. We store it in this variable message, and then we call emoji converter and pass this message. This function should return a value. That is what we calculate at the end of this function. So right after this for block, we need to add a return statement. Return
I'm
output.
lost, man. I'm totally lost.
Now
I
that our
don't
function returns a
understand.
value, we can get it and store it in a separate variable. Let's call that result. And then we can simply print that here. Or we can make this code shorter. We don't really need this variable here. So we can simply call the emoji converter and print the result. Like this. Now here we have another line because, as I told you before, we need 2 blank lines after our function definitions. So currently we have only 1 blank line. We need to add another blank line. Good. Let's go ahead and run this program to make sure everything works as before. So I'm going to type a message like good morning with a smiley face. Good. Let's run it one more time. I'm sad. Too bad. Okay, beautiful. So here's the final result. We defined this function called emoji converter. This function takes a parameter called message and finally returns the output.
I didn't get any of that. Any of that.
In this tutorial, I'm going to teach you guys
Zero.
how to handle errors in your Python programs. So let's start by writing a small program to get the user's age from the terminal.
Yeah.
So we call the input function input, add a label here like age. This returns a string, so we need to pass it to the int function and then store the result in a variable called age. Now let's print age to make sure we have implemented everything properly. Run our program. We type 20.
We get 20. Okay. Alright. Age equals int and here parentheses and here. And then here print age. Okay. Age. Cool.
20 is printed here. Beautiful. Now look at the exit code of this program. Exit code 0 means our program terminated successfully. There were no errors.
Okay.
But what if we run this program one more time, and instead of entering a numerical value, we enter something like ASD. We get a value error with this message, invalid literal for int with base 10.
Yeah.
Basically what this message is telling us is that this string ASD does not contain a valid whole number that can be converted to an integer.
Right.
Now look at the exit code of this program.
One.
Exit code 1 means our program crashed. So 0 always means success, and anything but 0 means crash.
Right.
Now, as a good Python programmer, you should anticipate these situations. You don't want to let your entire program crash just because the user entered an invalid value. So instead of letting the program crash, you should handle this situation and print a proper error message. And that's what I'm going to show you in this tutorial. Now, before going any further, look at the type of the error we get here, value error.
Value.
So remember this. We're going to get back to this shortly.
Okay.
Now, how can we handle these errors?
Wait, I think I know. I want to try. You need to put if, right? No? Not if? Wait, let's see.
In Python, we have a construct called try except. We use that to handle errors. Let me show you how it works. So, on the top, we type try colon. Now, as you know, we're defining a code block. So, I'm going to move these two lines inside of our try block. So, press tab here and remove this blank line. Now, these two lines are part of our try block, right? So, after try, we type except, and then we add the type of the error that our program may encounter. That is value error. Okay? Then we add a colon, and in this block, we can define what should happen.
Wait. After what? Value error? That's what I should write? Okay.
If our program encounters an error of type value error.
Oh.
In this case, we want to print a proper error message.
Right.
So print invalid value. So with this try and except, we're telling Python, hey, go ahead and try running these two lines of code.
Right.
If you encounter an error of type
value
error, then instead of
print
crashing the
invalid
program,
value.
print this error message on the terminal.
Okay.
So this is how this works. Now, more accurately in programming terms, we refer to this kind of error as an exception. So an exception is a kind of error that crashes our program.
But I think we faced this Ariel in this tutorial. We faced this problem and we solved it by if, probably. That's why the first thing came to my mind.
So if the user enters an invalid value, this line of code, line 2, will raise an exception, and on line 4, we'll catch it and print this error message so our program will no longer crash. Let me show you. So let's go ahead and run this. Age 20, everything works just like before,
Invalid
and
value.
the exit code is 0. Beautiful. Let's rerun this program and enter ASD. So we get this proper error message, invalid value, and once again, the exit code is 0. So that
Right.
means our program
Cool.
completed successfully, didn't crash.
Amazing.
Now, we can also handle different kinds of errors or exceptions.
Yeah.
For example, right after we get the age, let's define a variable, income, and set it to 20,000. And then define another variable called risk and set it to income divided by age. Let's run this program and enter 0 as the age to see what happens. So 0 is obviously a numerical value, so when we enter this value, technically we shouldn't get any exceptions. Take a look. Our program crashed with a 0 division error because we cannot divide a number by 0. Once again, look at the exit code. So we couldn't catch this kind of error or this kind of exception with this except block. This except block is only catching exceptions of type value error.
Right.
And this happens when we try to convert a non-numerical value to an integer. So in a situation like this, we should handle different kinds of exceptions. We can add another except statement for an exception of type 0 division error. Now in this block, we can print a different kind of message like age cannot be 0. Let's run our program one more time. Now I'm going to enter 0 as the age. So we get this error message, age cannot be 0. And look at the exit code. It's 0, so our program didn't crash. So to recap, we use try except blocks.
Let's see. 0. Age cannot be 0. Cool.
To handle exceptions that are raised in our programs. As a good programmer, you should always anticipate these kind of exceptions and handle them properly.
But what is the best way to deal with this problem? Is this except, like try except is the best way, or is it only for the sake of this tutorial? This is what I need to understand.
In this tutorial, I'm going to talk to you guys about comments in Python.
What if you guys give me 2 minutes? I want to refill my water cup and I'll put some music for you so you can enjoy. Lovely music, calming music. Cool. Be right back. Alright, welcome back. I hope you're having a good time. Don't forget to subscribe to the channel, that's gonna help me a lot to keep share with you my learning process. And let me just turn this off. Let's continue.
We use comments to add notes or comments to our programs. For example, here I'm going to make a print statement. Sky is blue. Now, Before that, I can add a comment using a hash sign, and then whatever I type here is going to get ignored. It's not going to get executed. Let me show you. So let's run this program. Look, we only see this message. Sky is blue.
Right.
So with this comment, we can explain something about our code. We can use that as reminders to fix things or clean things up, or we can use it to communicate things with other developers reading our code. Why we have written this code in a certain way. These are good use cases for using comments. We can also have comments over multiple lines, so we can simply add more comments. Each line should start with a new hash sign. Now, one thing you need to avoid when using comments is explaining what the code does. So here's an example of a bad comment. Let me just delete these 2 lines. And with this comment, I'm going to say print sky is blue. Why is this a bad comment? Because it's telling me the obvious. It is obvious that the next line is going to print sky is blue. Now, the problem with this comment is that apart from being verbose and repetitive, if we come back here and change sky to ocean, now this comment gets outdated. So every time we change this code, then we'll have to come back and modify the corresponding comment. So I've seen some developers add comments in front of their functions. For example, they define a function, let's say square, that takes a number and simply returns number times number. Well, it is obvious that this function calculates and returns the square of the given number. So there is really no need to add a comment and explain that. Calculates and returns the square of a number. This is very repetitive and it creates noise in your code. Someone else reading your code, they get distracted with all these unnecessary comments. So use comments to explain whys and hows, not whats. If you have made certain assumptions, you can use comments to explain those assumptions. Or you can use them to add notes to remind yourself or other developers to do something in the code. So comments are good, but too much of a good thing is a bad thing.
Interesting. Are we good?
In this tutorial, I'm going to talk to you guys about classes in Python. Classes are extremely important in programming and they're not specific to Python. In fact, a lot of other programming languages do support the notion of classes. We use classes to define new types. For example, so far, you have learned about the basic types in Python like numbers, strings, and booleans. These are the basic or simple types in Python. You also learn about a couple of complex types like lists and dictionaries. While these types are extremely useful, they cannot always be used to model complex concepts. For example, think of the concept of a point or a shopping cart. A shopping cart is not a boolean. It's not a list. It's not a dictionary. It's a different kind of thing. So we can use classes to define new types to model real concepts. Now, in this tutorial, I'm going to show you how to define a new type called point. And this new type is going to have methods for working with points. For example, back to our main program, let's create a list, numbers, 1, 2, 3. You know that here, when we type dot, we get access to these functions or methods available in list objects. Now, similar to this, we're going to create a new type called point. This point is going to have methods like move, draw, get, distance from another point. These are the operations that we can perform on points. So let me show you how to do this. We start by defining a class using the class keyword, and right after that, we give our class a name. Now look at the naming convention I have used here. I've capitalized the first letter here. This is what we call Pascal naming convention. So the convention we use for naming our classes is different from the convention we use for naming our variables and functions. For variables and functions, we always use lowercase letters, and we separate multiple words using an underscore. But when naming classes, we don't use an underscore to separate multiple words. Instead, we capitalize the first letter of every word. So in this case, our class has only a single word. If it had multiple words, let's say email client, look, I've capitalized the first letter of every word. Once again, this is called Pascal naming convention, and it comes from the old Pascal language that you might have heard of. So back to our point class. Here we add a colon, which means we're going to define a block. Now in this block, we can define all the functions or methods that belong to points. For example, we can define a function called move for moving a point. Now note that as soon as we type open parentheses, PyCharm automatically adds self here. This is a special keyword, and we're going to get back to this shortly. So for now, in this method, let's print move on the terminal. Now let's define another method like draw. So define draw, and in this method, let's print draw on the terminal. Now let's remove the indentation. We're done with the definition of our point class. So we need to add 2 line breaks. Okay. So with this class, we defined a new type. With this new type, we can create new objects. So an object is an instance of a class. A class simply defines the blueprint or the template for creating objects, and objects are the actual instances based on that blueprint. So we could have tens or hundreds of points on the screen. These are the objects or the instances. So to create an object, we type out the name of our class and then call it like a function. This creates a new object and then returns it. So we can store that object in a variable. Let's call that point1. There you go. Now when we use the dot operator, look, we have these 2 methods that we defined, draw and move. We also have a bunch of other methods that start with 2 underscores. These are called magic methods. We'll look at them later in the course. So now let's call the draw method of our point object and run our program. So you can see draw is printed on the terminal. Now, apart from methods, these objects can also have attributes, and these attributes are like variables that belong to a particular object. For example, here, after we define point1, we can set point1.x to 10 and point1.y to 20. Now we can easily print out these attributes. Let's print point1.x and run our program one more time. Take a look. So the x coordinate of point1 is 10. Now we can create another object. Let's call that point2. So point2, once again, we type out the name of our class and then call it like
print point, right, point1 dot x, right, print please, thanks. And then what is this? Point1 dot draw point2 equals point no equals capital P point. Okay,
function. Now this object is completely different from the first object. So if we print point2.x, look, we get this attribute error because this point object doesn't have an attribute called x. So each object is a different instance of our point class. And here we can assign a value to point2.x. Let's set that to 1.
But isn't that supposed to be 2, right? Yeah. Now we put two dot x equals 1, and then print point dot x, point2 dot x. Okay,
and then run our program. So we can see the x coordinate of point2 is 1.
Why he has draw in here but I don't?
So to recap,
no, it's not printing. Wait, what I'm doing wrong? I don't understand. Okay. Well, why this is not working now? Oh. Okay.
We use classes to define new types. These types can have methods that we define in the body of the class, and they can also have attributes that we can set anywhere in our programs.
Construct what?
You have learned how to create new types
What was
using
that?
classes. Now, there is a tiny problem in this implementation. We can create a point object without an x or y coordinates. Let me show you. So point, we create this object here. And before we set point.x, let's print point.x. Run our program. We get this attribute error that you saw in the last tutorial. So point object has no attribute called x.
Right.
This is the problem we have here. It is possible to have a point object without an x or y coordinates. And that doesn't really make sense because whenever we talk about a point, we need to know where that point is located. To solve this problem, we use a constructor. A constructor is a function that gets called at the time of creating an object. So here on line 9, when creating this point object, we want to pass values for x and y coordinates, let's say 10 and 20. And with this point object that we get here will have its x and y coordinates initialized. So how do we do this? We need to add a special method in this class called constructor. So on the top, we define a new function. Look at the name of this function, double underscore init double underscore. So init is short for initialize. And this is the function or the method that gets called when we create a new point object. Now, press enter. So this automatically adds self in parentheses.
Okay.
We're going to come back to this shortly.
Okay.
Now, right after self, we want to add two extra parameters, x and y. So let's type out x and y. And then in the body of this method, we should read the values passed here and use them to initialize our object. So when we pass 10 and 20, these arguments will be used for x and y parameters. Now to initialize our object, we type out code like this, self.x equals x. And then self.y equals y. What is going on here?
I
This
have
self
no
that you
idea
see
what's
here
going
is a
on. Don't
reference to the
trust
current
me. I
object.
don't know.
So back
Sorry,
to
go back a
object, we
little bit.
type out code like this, self.x equals x. And then self.y equals y. What is going on here? This self that you see here is a reference to the current object. So back to line 13, when we create a new point object, self references that object in memory, the same object that we are referencing using this variable.
Right.
So earlier we typed point.x equals 10. With this code, we set the x attribute of this point object. Now what we have in the constructor is exactly the same. We're using self to reference the current object, and then we set the x attribute to the x argument passed to this function. So using this init method, we can initialize our objects, and we refer to this method as a constructor. This method is used to construct or create an object.
Dude,
Okay?
I have no
So,
idea what is going
now-
on right now.
Let's remove line 14. So we create a point object with these values and then print point.x. Let's run our program. There you go. X is 10. We can also change these values later. So just before printing point.x, we can set point.x to 11 and then run our program. So x is updated. Beautiful. All right, here's an exercise for you.
Okay.
I want you to define a new type called person.
Okay.
This person object should have a name attribute as well as a talk method.
Okay.
This is a very easy exercise, so you can tackle it in probably a couple of minutes.
All right. Then person. Hey. Wait. Person, right? Okay. Point person. Person equals person. What do you mean talk?
It's an exercise for you. I want you to define a new type called person. This person object should have a name attribute as well as a talk method.
Talk method? What is that supposed to mean, my man? A talk method. Let's forget about that for a minute. Let's see here. Oh, nope, nope. Sorry, nope, nope. Now move, now. Name. Shut up. Print. Name. And talk. Now, this is two different stuff. So let's just delete this because we don't want it anymore. And here, self xy. No, we don't need this anymore, do we? No, we don't. Oh, self. And talk, I don't know, talk, and here self dot talk equals right equals blah blah. Let's see. And here delete define print point x. Now wait. Name no. Wait. Person equals person. Yes. Wait. Then here, what is person dot name equals Alex. Print person. No, definitely incorrect, dude. Invalid. Okay. Print person dot name. Okay. What about the talk? Anything? No. Okay. What is the name? What if we just put it here? Would it work? Person talk equals yes. No?
This is a very easy exercise, so you can tackle it in probably a couple of minutes.
Really? No.
All right, so first we start with the class keyword. We define this person class. Once again, look at the naming convention I have used here. The first letter of the first word, in this case, the only word, is uppercase. Now, in this class, we define all the methods that we need.
Okay.
Currently, we have only one method, that is the talk method. So define talk. PyCharm automatically adds self. We come back to this shortly. For now, let's just print talk. So this is the body of our person class. We remove the indentation and add 2-line breaks after defining our classes. Now we can create a person object. Let's call that John. We set it to person. We can call John.talk. Let's run the program. So we get this message, beautiful. But our person objects should also have a name attribute. It doesn't make sense to have a person without a name. So that is when we use the constructor function.
Dude, would you just give me a second because it's not working for me and I don't understand what are you talking about right now. John dot talk. No, I don't have it. What are you talking about?
.talk. Let's run the program. So we get this message, beautiful. But our person objects should also have a name attribute. It doesn't make sense to have a person without a name. So that is when we use the constructor function. So on the top, we add a new method. The name of this method is double underscore init double underscore. So we call this method a constructor. Now, in this method, we need to add another parameter that is name. So we simply set self.name to name. Once again, self references the current object. So we're setting the name attribute of the current object to the name argument passed to this method. With this, we can go back to line 9. And when creating a person object, we pass the name. Let's say John Smith. Now let's print john.name and run our program. There you go. So John Smith is printed on the terminal. Beautiful. So this is all you had to do as part of this exercise. But let's make this program a little bit more interesting. Instead of printing this boring message here, let's print, "Hi, I am John Smith." So we can use a formatted string with a message like, "Hi, I am." Now we want to dynamically add the name of this person. How do we do that? Well, look at the parameter of this talk method. As I told you before, every method in our class should have this parameter, self. And this should be the very first parameter of every method, okay? So with this self, we can get reference to the current object. So we can add curly braces and type out self.name. This returns the name attribute of the current person object. With this, we can remove line 10, where we print john.name, and simply call john.talk. Let's run our program. "Hi, I am John Smith." Beautiful. Now we can create another person object. Let's say Bob is a new person called Bob Smith. When we say bob.talk and run our program,
Right. Okay. Bob equals what? Person Bob Smith, right? And then Bob talk. Bob.talk. I don't know what that means. Alright.
we get a different message. "Hi, I'm Bob Smith." So each object is a different instance of a person class.
But you didn't. Oh. Where is the here print? I need a break, man. I really need a break. So we exactly have 3 hours left on this. So I think let's call it for today. We'll continue later. Thank you so much for watching, guys. If you want to help me achieve my dream, please subscribe to the channel, hit the notification button, and write in the comment section whatever that might help me. I left some links that might help you over the things that I went through, short videos and this tutorials link. So thank you so much.